Welcome students. Today we will see torque on dipole in uniform electric field. What is uniform electric field? Electric lines of force are parallel. This is uniform electric field. So what are you guessing from this? This side is positive, this side is negative, but uniform from the source. Now let us think for electric dipole. Let us take a dipole. Let this is the dipole. Let here minus q is there, here plus q is there. And what is the length? Length is 2L. This total length is 2L, as usual, dipole length. What are you observing from here? This side is plus, this side is plus. Obviously this will be the force acting this side. Now this is minus, this side is plus, force is this side. So either side force is equal because it, and this force will be equal to QE. Now two forces parallel in opposite direction and not collinear will constitute torque. What is the torque? Force into perpendicular distance or moment of R. Let us draw the perpendicular line. Let this point is A, this point is B, this point is C. So I will tell this is the perpendicular distance. So what I want to know? Torque. Torque equal to force into perpendicular distance. Now what is the force QE? We know. What is the perpendicular distance? Let they are making an angle theta to electric field. If it is theta, what do you know? D and 2L. For theta, this is P, this is H. That means from triangle ABC, sin theta, P by H, that is D by 2L, or D equal to 2L sin theta. Mark it equation 1, equation 2, equation 3. So from equation 1, 2 and 3, tau is equal to force, that is QE, perpendicular distance, that is 2L sin theta. Now the question is 2LQ. We know this is dipole moment. So torque equal to PE sin theta. I will write here, since 2LQ equal to 2QL equal to dipole moment. So torque equal to PE sin theta. My question is now, what is its vector form? This is the scalar form. So vector form, torque is equal to P cross E. How to know its direction? This is P direction. Dipole moment minus to plus. This is electric field direction. Now P cross E for our case, torque direction is downward. This is one part. Another part generally asked, find the potential energy of dipole in uniform electric field. That means I want to know potential energy of dipole in uniform electric field. Now my question is, how to find it? We got tau is P sin theta. Like the work done, force into distance in angular case, this work done or this potential force for linear case you can compare it to the torque, and displacement in linear case you can compare to theta. That means I want to find out the worklet and elementary work done dW is done. Let us rotate it to an angle theta. Rotate it to an angle theta. That means what I got? dW is equal to tau d theta. Let me tell you some concepts I forgot to tell. Let us finish it here. Suppose I am telling case 1 for torque. When theta equal to 0, this is known as stable equilibrium. Theta 0 means tau equal to 0. That means dipole moment direction and electric field direction are same direction. So what will I write? Direction of P vector and E vector are equal. Let us go for the case 2. Theta is 90 degree. Theta 90 means this is the situation. Dipole moment is perpendicular to E. So tau I will get PE sin 90. Sin 90 is 1. Tau equal to PE. So this is maximum torque. Which situation? When P is perpendicular to E. Dipole moment is perpendicular to electric field. Let us come to this point. So dW equal to tau d theta. Tau is what? That means what I got here. That a small elementary work is done to rotate theta. To rotate theta by the help of torque tau. So small elementary work done is dW, that is tau d theta. Tau is from this, let us mark it equation number 4. This is equation 5. So from equation 4 I can write this is PE sin theta d theta. I want to know, let us rotate it from theta 1 to theta 2. From angle theta 1 to theta 2. What is the net work done? So net work done will be equal to limit theta 1 to theta 2. You have to write here. Let net work done W is done to rotate this dipole from angle theta 1 to theta 2. PE sin theta d theta. Now the question is P and E are constant. I am moving it outside. So this is theta 1 to theta 2 sin theta d theta. Sin theta integration is minus. I am taking minus outside. Cos theta. Limit is theta 1 to theta 2. So I can write it now minus PE cos theta 2 minus cos theta 1. Or I can write W equal to PE cos theta 1 minus cos theta 2. Any one of the formula you have to remind. No problem. If you are taking final to initial, it will become minus. If you are taking initial to final, it will become plus. Now, some special cases are there. Let's go for those cases. What we got the formula? PE cos theta 1 minus cos theta 2. Sometimes questions will be asked, find the work done in rotating the dipole in uniform electric field. What is the question? Work done or potential energy they can ask. This work done, what we got here, that is stored as potential energy or potential energy required to rotate dipole in uniform electric field. Some special cases are there. Suppose I am telling the past situation, I am rotating 90 to theta. That means what I am telling. Let us check it again. Suppose I want to rotate 90 to theta. That means initially it was theta equal to 90. So theta 1 equal to 90. And dipole moment what I told, 90 to along the direction of electric field, that is 0. So theta 2 equal to what I am telling now, to 0 degree. So in this case, my potential energy, or what is that work done, will become, which formula? Any one you choose. Suppose I am choosing the last one, so I will write PE cos theta 1 minus cos theta 2. So theta 1 is cos 90. I will write it here, cos 90 minus cos 0. Cos 90 is 0, cos 0 is 1, so I am getting minus PE. So my work done will be equal to minus PE. Suppose I want to know theta 1 equal to 90 to any theta. From 90 to theta I want to rotate, any angle theta. How can I get? So similarly my potential energy will be equal to PE cos 90 minus cos theta. Cos 90 is 0, so I will write minus PE cos theta, or for this particular case I am getting, this is minus P dot E. Sometimes they will ask, suppose I am writing case 3 here, stable to unstable equilibrium. Stable to unstable. Let us know what is stable. Stable means theta equal to 0 degree. Unstable means theta equal to 180 degree. So what is stable equilibrium? Let's keep the pen here. If I disturb, after some time it is returning back and remains equilibrium. This is known as stable. That means it will be in equilibrium. If I will disturb, again it will return to its previous position. Unstable means this is in equilibrium position. Okay. If I will disturb, after some time it will be also in equilibrium, but not in the initial point. So this is unstable equilibrium. In this case what happened? Dipole is like this. This is stable equilibrium. If I will disturb it, it will rotate. After some time it will be fixed. This is unstable equilibrium. If I will disturb it, it will rotate and it will come to this position. That's why 180 is unstable equilibrium and 0 degree is stable equilibrium. Let us go for, that means theta 1 equal to 0 degree to theta 2 equal to 180 degree. So my potential energy or work done, whatever you are asking, that is equal to cos 0 minus cos 180 degree times PE. Cos 0 equal to 1, cos 180 equal to minus 1, minus 1 plus 1, plus 1, 2. So I am getting 2 PE. So I think you got the idea. So let us summarize the concept. Whenever electric field is uniform means they are parallel to each other. This side arrow mark means this is plus, this side is minus. Whenever dipole is situated like this means dipole moment direction is minus to plus. So now you got how force is generated. Force is perpendicular distance. How we got the perpendicular distance. Now you got the torque. Torque direction you can apply by right hand thumb rule, P cross E. Second thing is how to find out work done. Like our work done is force into distance. In this case torque into angular displacement. Similarly you can get it. And this is the process. Thank you.